Hello. Hey, thank you for joining Solid Edge University 2021. Thanks for taking the time to check this out. I should let you know we are recording this. So if you can't stay for the whole thing or get interrupted or whatever, you'd be able to watch some of these details later. This first session goes for about an hour, and then we have two more hours of deep dive sessions that we'll cover. And there will be some poll questions in between, just to get a pulse on what you think so far and how you're doing with Solid Edge. And you can ask questions anytime you want. There is a questions panel on the right part of your screen. We'll be collecting those questions as we go along and answering them for you, answering live. So I guess we'll just jump right in and get started. And thanks very much for joining. So Maya HTT, we provide software-driven solutions. Actually, we've been awarded the #1 worldwide partner for Siemens this year, which is awesome. And we're a group of very passionate engineers. Actually, 75% of our staff are actual scientists and engineers. And we started in space and are recognized worldwide for our multiphysics simulations. And our engineers have a lot of sought after hands-on experience in almost every industry that we serve. From satellites to tomatoes, we do it all. Yes, tomatoes. We not only developed over 30 software modules for Siemens as an OEM, we now have millions of users all over the world. We help our customers put satellites into space and reduce energy consumption data centers. We help them design zero emission vehicles, deliver tomatoes to customers, and we find better ways of doing engineering. Hello, and welcome to Solid Edge University 2021. My name is Rick Loring, along with Jason Titcomb from Maya HTT. We're going to show you some of what's new in Solid Edge 2021. As you probably know, Siemens Digital Industries software is all about helping you harness the power of digital transformation to develop products better and faster and more efficiently. They're known for bringing technologies of tomorrow to our customers today. And here, Solid Edge 2021 is a perfect example of that. Solid Edge 2021 from Siemens provides you the speed you need to get the most out of your entire engineering process, maximizing productivity and decreasing costs. Today, we'll take a peek at 7 areas in this latest release. First, there's mechanical design. You can design at the speed of your creative thought with new subdivision modeling, very fast reverse engineering, a new user interface that's powered by artificial intelligence, and an intelligent 3D model search engine. There's electrical design, enable fast, accurate 2D layout of industrial control panels and a new cabinet design capability. Simulation, optimize and validate designs with tighter integration between flow and structural simulation. Manufacturing, speed up NC programming with a searchable post-processor database and new roughing and adaptive milling. Technical publications allow you to produce high-quality documents and illustrations faster directly from your 3D models. Data management, take control of your data, saving time and money with rapid concept modeling and shape search capabilities. Finally, cloud-based collaboration, harness the cloud to edit and share a variety of CAD files and much, much more. Our customers are calling this the best release in years. We'll start with a question. Where can digital transformation take you? How can you use digital transformation to make your business more productive and more profitable? So there are typically 3 fundamental pieces to your business process. You have design, where you design the products. Then you have to realize those products to actually make them through all the production phases. Then you have to optimize these products, typically in a long iterative process after you get them into the field. You also have to get data back and be able to figure out how to make these products better. So what's happening right now in these worlds that were kind of separate are gradually collapsing. Design, manufacture, and optimizing are all pulling tighter and tighter together. Think of the digital twin not so much as just a CAD digital twin, but also a manufacturing digital twin, where you take data back from the field in a tight closed loop and bring it back to help design and manufacture products better. This is what Accelerator enables, the digital transformation. With the comprehensive digital twin at the core, the design, realize, and optimize we just mentioned, you have model-based systems, collaboration, and analytics to create this unique digital fabric, getting you to the future fast and predictably. It's important to understand that Solid Edge is a lot more than a CAD system. Indeed, it's the best mechanical design system on the market, but what about the rest of the things you need to do as a business? Electrical design, simulation, manufacturing are all part of the Solid Edge portfolio, along with technical publications, data management, and now cloud-based collaboration as well. Regardless of how small or large you are, we offer the tools you need. The full portfolio of Solid Edge is not only available to commercial customers, but also to students and startups. Not just mechanical CAD, though, we also offer electronics, CAE, CAM, technical publications are all available completely free for both of these. Now, let's introduce Solid Edge 2021 and see how it can help your digital transformation journey. We're going to start by using a data set and talk through the enhancements. A machine that makes ice pops. We want to thank our customer, Finamac. Finamac had a great idea. They said, how can we take aerospace technology and apply it to machines that make ice cream, ice pops, and chocolate? They certainly have transformed their business while disrupting an industry by leveraging the digital transformation. If we take a look through their catalog, you can see all sorts of things. Ice cream making machines, chocolate display cases, ice pop machines, mixture preparation machines, all beautiful designs. An amazing thing about this, however, is that none of these photos are actually real. What you're seeing are digital twins. Every picture here is straight from Solid Edge, rendered and put into their catalog. This is an example of the digital twin at Finamac. So let's begin with mechanical design, the core of what you guys do. This year, we have new subdivision modeling techniques, very fast reverse engineering, artificial intelligence capabilities, an intelligent 3D model search engine that I think you'll like. Let's go through them one by one. Subdivision modeling, reverse engineering, adaptive UI, core CAD, the stuff you do daily, and supplier catalog integration. These are just a few of the things we're highlighting today. There's a ton of new stuff in Solid Edge 2021 as well. So subdivision modeling, this is an amazing technology that allows anyone to create beautiful shapes. In the past, this was really the domain of a specialist who could handle NURBS and surfacing and all those complicated things, but now anyone can create these smooth and organic shapes. So let's jump into the Finimac machine and let's focus on the design of a portable controller. Sub-D modeling enables you to develop distinctive organic shaped products without the need for expert skills and knowledge. So if you're not the best at surface modeling, for example, here's your chance to surprise your team. We'll start with an industrial design sketches. We'll use these as a guide. So subdivision modeling can be simplified in 3 steps: the initial shape, the control cage, to push and pull, and blend options. We'll start here with a box shape and push and pull out the lower portion of the control cage. That gets a general shape of the controller. We'll start there. It's just a block, and we'll put in some starting dimensions. We can push and pull and get the general triangular shape of this controller. And after this, a split operation can be used to subdivide the control cage, which in turn gives us a lot more control over the shape of the body. The control cage can be adjusted, and we can accommodate room in the central area we need for the controller screen. A simple lift operation adds the necessary faces to the model. A blend function can then be used to control how sharp or smooth certain edges are. While you might expect that they have only smooth edges, it's not the case in Solid Edge. You can choose sharp blends whenever you like. Then, to create a cutout for the screen, a series of similar push and pull techniques are used to get our desired result. Many of the parts here need to be designed symmetrically, and to achieve this, we simply define a symmetry plane. Then, any edits made on one side of the cage are reflected on the opposite side, as you can see here. Anyone that's used synchronous technology in the past will be familiar with the steering wheel, which is equally at home here in manipulating the organic shape. For the top notch of the part, we do a simple move face operation, which creates the geometry we need. And to keep track of what edges that we blended and the value of each blend, we can show the blend values at any time for every edge and every vertex. Well, we need to create a handle now. And we're not going to just cheat and pull something already done. What we're going to do is just do the same rectangular shape on this on the fly and see how easy yet powerful it is. Same as before, we'll grab an initial rectangular edge or shape, extend it, and then use a control cage to push and pull it into shape, followed by a blend operation. Done. An important point we make here is we still use traditional solid, the Solid Edge tools like the shape. The shape tool there. We use that to split, and we can then grab those faces and thicken them. We can use Part Painter to color them to have that stand out a little bit better. And you can still use any of the traditional solid modeling tools to further develop this model. So we'll turn off some planes here. We'll do some rendering, and within just a few minutes, we've got a very complex model. Not bad. Now, I've been around the industry for a while, and I've seen what it takes to do this kind of modeling, literally days to do a model like that. And to see it done so quickly, step by step in front of us, I think it's truly amazing. You can see how easy it was to create these shapes. You just used a polygonal cage to manipulate our shapes. It takes a little while to get you the hang of it, but once you do, it goes really, really fast. What's nice is we're right here inside Solid Edge. It's built right in. There's no specialized tools, no other products to buy, and it's available to you in Solid Edge 2021. We're seeing some great feedback from our customers around this. For example, Jason Inglis at Ditch Witch. Ditch Witch makes earth-moving equipment. They're using more and more stylized shapes, and they want to see these used in their industrial designers and to see what they can do with technology like this. Next up is reverse engineering. We'll introduce reverse engineer. We introduced it actually a couple of years ago, and we've been continuing to invest in it, making it faster and adding new features to it. I think you'd be really pleased with what we have in Solid Edge 2021. Let's take a quick look here. So we'll take a look at this recent edition. There's a new Solid Edge toolset called deviation analysis. It allows you to measure the accuracy between the original scan and the resulting reverse engineered model, or even compare the two scans. The result plot color codes deviation for easy interpretation. Red means the test body exceeds the reference body. Dark blue depicts negative distances. On the on-screen callouts, identify minimum and maximum deviation. You can copy and paste this data for reporting later. Settings such as deviation range and result decimal places can be adjusted at any time, making just a few seconds for the model to recompute. So as you just seen, there's some great new capability in reverse engineering. Deviation analysis can tell you how much of the digital twin you've made from the real world product deviates from the model. Just as importantly, it's really, really fast now. Things that used to take minutes now take just seconds. Adaptive UI. Now, this is a great new technology that we're pretty psyched to show you. It uses artificial intelligence to predict what you do next. How does it do that? It looks at what you've been doing in the past, at your patterns, and it figures out what you might do next and presents those options to you. It's not just remembering your last 3 commands. So it's really groundbreaking technology. So keep your eyes in the top left screen. Solid Edge 2021 includes an artificial intelligence-based assistant in its user interface to predict the next commands you need based on what you're doing and where you are in a design. So for the FineMac machine, there's lots of sheet metal work. And Solid Edge 2021 has learned from the design engineer, rather than presenting tools that are commonly used across the industry, which would be good, it's presenting tools commonly used to this individual, which is excellent. That's right. So Solid Edge 2021 now individually tailored to you. And what's more, it will continue to learn from you and dynamically improve how it holds your hand through your work day to day. And it's what's really interesting here. It's interesting to watch, dynamically presenting the next selection of tools, even across different environments, as we go from sheet metal to sketch and back, presenting specific commands. I said at the start to keep your eyes in the top left of the screen, and notice there's just one toolbar there. That means you can remove the other toolbars and maximize your workspace to have what you need right there, and it's ready when you are. So, as you saw, we're harnessing the power of artificial intelligence, and you can see how it can be applied to your daily work. It's personalized for you. It actually learns from you. What it does the first day of usage versus what it does a week. After a week will be different because it learns as you go. Great thing about it is you can also share it with other people in your company. Maybe your process isn't the exact same as others, but you may have similar work that you all do. You can give them a head start in learning by sharing your piece with them. In the area of core CAD enhancement, we have a lot here going on. As I said earlier, there's no way we can cover the depth and breadth of Solid Edge 2021 in this short update, but I want to show you a few things that would be really valuable in the day-to-day work for the stuff that you do every day. Let's jump back into the FineMac Popsicle machine. Actually, the name of this machine is Pop Circle. Get it? Anyway, first off, we're using large assembly mode to make the most of our computer's resources and to keep things performing as we'd expect. There's more to help with performance here too. It's common practice for suppliers to provide a 3D file of purchase items, such as a piston assembly. And using the new internal components option, all separate parts are contained within a single assembly file with no parts written to disk. This enables for faster import times, especially on large data sets. Even though these parts are internal, they can still use traditional operations, such as taking measurements or analyzing mechanisms. Here we see the correct operation of the piston assembly with its internal components. Further, you can then assemble this as if it were a regular assembly, All in all, it provides increased performance and a lower consumption of system memory. Reusing designs is even easier now. When copying and pasting multiple parts and assemblies between designs, existing assembly relationships are automatically captured and reused in the target assembly. A step-by-step process guides you through the operations to add assembly relationships needed to fully position the parts. All internal relationships come along for the ride. This significantly reduces time for these operations. There's a new multi-edge flange command that speeds up the time when designing sheet metal parts. Multiple edges can be selected at the same time. Angles can be defined and miters can automatically be added. It's as simple as picking the edges and then pushing or pulling. In addition, partial or center flanges can also be defined, and trim options can make easy work of tasks that would normally require multiple operations, even with offset or gap distances are required. These sheet metal enhancements, along with many others, increase productivity and efficiency, being able to design parts faster and easier. There's a new decal command. It makes it quick and easy to add labels and images onto parts. Simply select the desired image, define the desired size, and position it accurately using regular sketch relationships and dimensions. A decal can span multiple faces, as we see here. However, to change the position of it, you simply modify the dimensions or the relationships. Solid Edge 2021 also includes enhancements in frame design. Here we'll place a cross section which has coping applied so that it matches the circular cross section of the vertical frame. Now we can specify a weld gap between the frames, and this is especially important in generating an accurate cut length of welded frames in our parts list. A new end caps command also allows quick definition of these types of parts within a frame. The single command now provides a wide range of options. Simply select the frame cross-section, choose the material, and specify the type. Choosing from different types like inward or outward, or even define offsets that have chamfered corners. The end caps are reflected in the bill of materials, eliminating any additional work. There's some truly great stuff in here. And actually, this is just a bit of a preview. On large assembly performance, our customers are making larger and larger assemblies all the time, starting with a smaller assembly and getting bigger and bigger and bigger. Suddenly, they're doing a machine, and the next thing you know, they're doing a small factory. We're keeping up with that, continually adding capabilities to go bigger and bigger. Internal components. Now, this is an awesome feature. Today, it's used for importing parts, such as, say, an engine block or an engine assembly that has 300 parts in it, and you can add that to another assembly and not have to worry about all the individual part files, because honestly, you may not really care about all those. And maybe they came from a supplier. The internal components technology is going to allow us to leverage this in the future to do more and more exciting things in coming releases. The sheet metal advances are really amazing. We know a lot of our Solid Edge customers are customers because of sheet metal, because we're actually known as the sheet metal guys from early on and continue to be so. The ability to create multi-edge flanges and automatically trim them is unique in the industry, and it's even patent pending actually right now. A lot of machinery design customers are building frames, so we continue to build that out. Our new frame end caps command creates custom end caps, and there's new support for frame and weld end gaps. Finally, decals. As you saw, it's not just decals on a flat surface, it's curved surfaces. It's across multiple surfaces. It's really, really a nice implementation. We see our customers really enjoying the Solid Edge 2021 release. For example, Luca Carminetti at CMS has been working with the new sheet metal functionalities. They do a lot of sheet metal at CMS, and multi-flange and auto trimming is going to save them a bunch of time. So what about supplier catalogs? You're often getting different parts and data from your suppliers or from websites. Different people make different products that you incorporate into your products. What if it was easy to find a variety of ways to find the information and fit it into your design? That would certainly save a lot of time. So let's check it out. 3D Find It for Solid Edge powered by Cadenas, is the latest search engine for mechanical, electrical, and electronic engineering. Here, we're searching for a cable gland using text, narrowing down the search by filtering the supplier. We can even add additional search terms, in this case, filtered to the ISO standard. You can even search using 3D geometry, sketches, and more. You can visualize the 3D model for your part, even if it's a 2D drawing, select the relevant individual parameters for the part, and then a single click adds it to the solid edge assembly. You can save a lot of time and money in things that already exist, but it can sometimes be challenging to find them. So being able to find the suppliers that you're used to working with and getting the products directly from them will simplify the process. 3D Find It provides access to more than 1,500 CAD and BIM catalogs, which has a lot of interesting ways to search. Or, by the way, it's fully integrated with Teamcenter as well. The folks at Ditch Witch were very excited about this. The integration allows them to save a lot of time, not having to build parts, to rework parts, and just simply use what they already have. There's a lot of other stuff here in mechanical design, more than we could possibly cover. We'll invite you to look at it more deeply. But Solid Edge is not just for mechanical design. As we were talking earlier about the digital twin, you should really look at your business and think, not only how can I be more productive with mechanical design, but how can I expand my efforts? Can I go further in my production process, or can I go sideways into electrical design? What ways can I become more productive as a company by using the tools that enable digital transformation? Electrical design is becoming a lot more integrated with mechanical design. These efforts are called electromechanical design. So I want to talk more about that. But before we go there, I just want to mention, when we first saw this picture here, I thought it was a real product. It's not a real product. It's a digital twin of a control panel. It's amazing what we can do these days. There's a lot of talk about electrical design. First is wiring design. It's a really important thing coming here in Solid Edge 2021, and that's cabinet and panel design. It's a different thing when you're wiring a tractor or a car than it is when you're creating industrial control panels and cabinets that go into the machines that you design. We have a full complement of tools here. We're going to check these out. So here we are in Solid Edge wiring and harness design. And we're going to add the existing electrical design work of the Finimac machine by laying out the machine's control panel. Solid Edge 2021 has new cabinet and panel capabilities that allow us to reuse the schematic intelligence to generate the panel layout. Placing the correctly sized cabinet based on our specs, we can add additional items such as backplates, channels, mounts, and other hardware. We also need to add some wiring ducts. So here we'll place a series of channels. Dynamic dimensioning provide accurate feedback, and industry standard profiles are available. Using the mount command, we can add the necessary DIN rails, which will attach the electrical components. Again, accessing the properties allows us to choose from industrial standard sizes and profiles. Adding some dimensions to the mounting plate as well as the channels and rails will help document their position. Associating a new layout to the schematic allows us to place the relevant logical electrical components. Placing the devices is simple. There's a number of ways that we can do this. We can place single objects or multiple objects at the same time, and shortcut options also allow control over snap points, rotating angle, and the order of the placement, and more, all of which are dynamically previewed during the placement process. The last few devices are placed in the top and bottom rails quickly and easily. A bill of materials, which is customizable, has been automatically built, and we've added the devices to the layout design. A bill of material IDs can be generated with balloons. Finally, for the panel is a terminal plan, which assists in the assembly and wiring of the terminal strips. The fully associative terminal plan are automatically generated, documenting the terminal blocks along with their specific symbol, physical sequence, and the strip, and the details of where the wires terminate to both ends of the block. Now that the electrical design and documentation is complete, we can finally share this with our MCAD team. The connected mode makes it easy for the ECAD and MCAD worlds to collaborate. Switching to Solid Edge 3D CAD, we can see the existing wiring details that have already been added to the design. With the connected mode active, we can cross-highlight components between the two disciplines. We'll bridge in some of the final conductors to connect the two cabinets together. We can bundle these wires together. And to keep the bundle neatly organized within the assembly, there's a new route along surface command that provides a very efficient way of routing the bundle path around the contours of the frame. All that's needed is to pick a bundle to be rotated, or to be routed, selecting the faces of the geometry the bundle needs to follow, and plot some points along to define the path. Then route the ends of the bundle through each of the glands to the respective cabinets. Just watching that is impressive. The amount of productivity you have in terms of laying out the cabinets and panels is pretty remarkable. If you're working with something that's using a more manual technique, you're going to find that this will add some serious productivity to your day. What you saw there, first of all, is that customizable table-based interface for the device snapping to the rails and so on. We didn't get a chance to look at it, but there's also an auto routing capability for schematics that will save you a lot of time. And of course, it's all upward compatible to the Mentor line of products. We got a glimpse of routing along irregular geometry. It can even be a sculpted shape, maybe something you did in subdivision surfaces. Connected mode in electrical routing has also been extended. And that's not only working with solid edge wiring and harness design, but it also works with Mentor Capital software. And finally, we have an integration to other third-party products as well. In the area of harness design, to be clear, when I talk about harness design, I'm not talking about the 3D efforts that mechanical engineers might think of. Harness design is also something you do in 2D. How are you going to lay out the harness for production? When we talk about harness design, that's what we're talking about here. You have the ability to visualize this in Teamcenter as well as tie it back to requirements. It enables tracing of the requirements themselves. And it also allows interactive routing for the full signal path. In the area of PCB, some great stuff here as well. It's all about the collaboration between electrical and mechanical and the ability to bring design aspects back and forth. Maybe propose a design change and accept or reject it. And it's all supported through the IDX 2.7 format. We also support the mapping of 3D models between Mentor Expedition and Solid Edge. We're seeing a lot of traction here with people who are adopting our portfolio products. Folks like Matthew Fresco at WashTec is also taking advantage of electromechanical capabilities. They provide a true digital twin. It's not just a mechanical digital twin, but digital twin that includes electrical design and really solves a bunch of problems that are found out in the field. You're going to find this a great area to expand into. Next up is simulation. And of course, there's a lot going on here. We have products for stress analysis, nodes and vibration, all sorts of different things, and flow analysis. You're going to see some great integration between our structural and flow products happening in Solid Edge 2021. So back to the Pop Circle machine. SimCenter Flow EFD and Solid Edge features new capabilities and modules for electronics cooling applications. The new package creator specializes in the rapid creation of accurate thermal models of electronic packages with correct definition of chip layers and solder balls on the chip. Here we can clearly see the thermal effect on the PCB board and in turn its effect on the overall electronic enclosure. Looking at the flow trajectories around the fan, this shows how the fan swirls the air and pushes it to the side to cool the enclosure. We can also see how the fan is performing along the fan curve, showing the operating point of the individual fans based on the fan curve data from the manufacturer. So ISO surfaces are another way of illustrating where the airflow is going and showing the velocity and the volume plot. In addition, Solid Edge 2021 now has the ability to apply the results from a computational fluids dynamic study as input to Solid Edge structural or thermal simulation study. Focusing on the tank containing the liquid bath that freezes the popsicles, looking at the results of the thermal flow study, we can see how the cooling liquid interacts with the assembly. And these results can be sent to Solid Edge structural simulation by using the export results command. So let's go to the structural analysis setup. Also new in Solid Edge 2021 is the ability to suppress and remove any components directly from the simulation pathfinder, making it easier to test the design on a subset of study geometry. When defining the material for the insulating core, another new feature is the ability to highlight key materials that are required for the study we are attempting to solve, as can be seen by the green coloring. It makes it easy to ensure we have appropriate properties defined for an accurate study. The last step before solving our structural study is to import the flow EFD pressure or thermal results. These are automatically applied directly to the correct bodies and faces in the study. In the result, we can see the pressure from the cooling liquid is causing the highest, where the pressure for the cooling liquid is causing the highest areas and stress on our design. And it doesn't stop there. New for Solid Edge 2021, the ability to probe edges, ultimately saving time and having to select each individual node. Like I said, I've been in this industry a long time, and I'm still amazed at some of the things that I see. The features around flow simulation, the integration of what the stress simulation is just utterly amazing. We continue to enhance the solid edge simulation in many ways, improving the interaction with the materials, making it easier to remove components from the study, being able to probe the geometry more easily. But really, that ability to tie the flow and structural together, that's impressive. We're able to take the information from the flow and read it directly into Solid Edge for, let's say, stress analysis. In addition to that, you saw the new Electronics Cooling Center. It has a full suite of capabilities for electronics cooling, and these are very strong capabilities. The other thing we added was something called BCI-ROM, which may mean nothing to you, but it should mean to you, what it should mean is months to minutes. This is, again, an amazing technology. A study that would have literally taken 6 weeks of CPU time can be done in 3 minutes. And in those 3 minutes, you'll be within 5% of what those 6 weeks would have given you. Truly amazing stuff coming out of the team, and invite you to take a look. Next up is manufacturing, accelerating your product development. Whether it's additive or subtractive manufacturing, we have some awesome tools for you. So let's jump right into Solid Edge CAM Pro. New in 2021 is Integrated Post Hub. It's an online library of post processors that makes integration with your machinery easy and quick. With new posts added regularly, the Post Hub is searchable with filters for machine type, manufacturer, controller type, and kinematic configuration. Once the desired post processor has been selected, it can be automatically downloaded and installed, and verifying the post output is simple. Solid Edge CAM Pro now has, check that out. So now has multi-axis roughing, which is a great tool for quickly removing stock from aerospace parts, like the one shown here. Multi-axis roughing uses adaptive roughing technology to machine parts in the most efficient manner. Viewing the multi-axis roughing path in replay mode allows visualization of the tool axis tilting as the cutting tool removes the material. The 3D dynamic simulation option shows the tool motion and concurrent material being removed. Now notice how the multi-axis roughing efficiently removes material without ever burying the tool in the cut. That's obviously extremely important for efficient machining. With machining simulation, users can view the actual machine motion, which delivers very high confidence level and is necessary for complicated multi-axis machining center. Solid Edge CAM Pro supports G-code-based simulation, meaning the virtual machining center is acting upon G-code just like the real machine would. We continue to push both additive and subtractive manufacturing forward. You can see in the new Post Hub library, getting access to proven posts for your CNC machine tool has been a constant industry issue, and it's much easier now with the Post Hub library. You also saw multi-axis roughing, and that's really state-of-the-art stuff. We've also included some things in additive we didn't get a chance to look at, but we are providing better material selection for your printing needs, and bringing various additive checkers into one comprehensive additive checker makes it a lot easier to interact with. Oh, back up here. Another part of manufacturing is nesting. A lot of what you do is sheet metal. We talked about sheet metal earlier, and the ability to lay those sheet metal parts out in the most efficient way possible. We have the most efficient algorithm in the industry for doing just that, and we want to talk to you about some of these new enhancements in that area. If your machine looks like this, consisting largely of sheet metal parts of varying materials and thicknesses, you'll really benefit here. So jumping into Solid Edge 2D nesting can now search the complete assembly for appropriate sheet metal documents, automatically sorting the parts by material, type, and thickness. By selecting the material type and then thickness, you can quickly make patterns for multiple jobs, enhancing shop floor efficiency. Flat patterns are then automatically extracted from the parts, saving valuable time. The assembly occurrence now automatically defines the part quantities, while the job multiplier quickly calculates the amount needed to manufacture multiple machines. Solid Edge 2D nesting supports multiple sheet sizes. Standard sheet sizes are stored in the library, and you can easily define your own custom sizes. And here, Solid Edge 2D nesting is doing its thing, finding the most efficient use of material. Savings in the material costs are also gained by the highly efficient algorithm and could quickly offset any of the software investment. And last but not least, 2D nesting has a quick cost estimator. From user-defined costs per square meter or yard, 2D nesting quickly generates an accurate cost of material that are needed for job cost accounting, quoting, and inventory processes. 2D nesting is a great opportunity to improve your sheet metal process while saving money. As I said, it uses the most efficient algorithm in the industry, and we've enhanced it to deal with odd-shaped sheets, like in the upper right corner here. The ability to nest something that may be cloth or leather or things that have an odd boundary are now supported. Adding the cost of material to the job multiplier makes it easier for you to get your job done. Sorting by the material thickness is also some really great stuff in Solid Edge 2D nesting, and I suggest we check it out. Next up is technical publications. Over the years, you've generated tons of Solid Edge data. What if you could take advantage of that and generate beautiful technical publications? Super easy. Well, it's faster than ever here in Solid Edge 2021. Let's put together an interactive maintenance publication, something that will be used on a touchscreen tablet by the maintenance department. A host of new improved functionalities make it simple and clear to create clear technical publications, whether for manufacturing or installation, or in this case, maintenance. It can be interactive content like this or a hard copy on paper printouts. The new selection capabilities in Solid Edge TechPubs allow for the organization of groups and parts and subassemblies into named sets, making it easier and faster to select or hide multiple parts at the same time. Here we'll focus on a single mold assembly and build a document that describes the cleaning process. The new View Carousel function makes it easy to navigate through the illustrations with a storyboard. Creating an interactive view is fast and easy. Here we can accommodate multiple 3D views on a single page. Selecting a part on the right displays the view on the left. The next page includes step-by-step instructions for cleaning the mold assembly. The best way to visualize the process is to mimic through the exploded view with dynamic text-based boxes providing instructions. Adding buttons to step through the process is made quick and easy by using the new manual markup resizing options. Now, not only can you import all native Solid Edge exploded views, but you can also create custom exploded views within Solid Edge technical publications. Adding interactive parts list is simple as drag and drop. The parts table is automatically displayed based on the 3D model's metadata or properties. A new powerful and versatile parts list editor makes it easy to customize the table, and adding an illustration allows us to quickly switch between the collapsed and exploded views of the mold assembly. The project can be published in industry standard formats such as 3D PDF, and in this case, HTML5. The rich interactive document can be viewed on any web browser without additional plugins. The new 360-degree publishing get an all-around view of your product. The automatic functionality allows for more robust presentation of your design, a great way to capture images for product and stakeholder meetings. Clickable SVGs is another new feature that allows us to publish an illustration with interactive SVG, single vector graphics format. When a part on the model is selected, the corresponding row in the table will also be highlighted. And furthermore, being SVG, it's very crisp and very clear. With technical publications, we see that you can take advantage of your data, the data that you have today. Customers have generated literally millions of parts, some upwards of 15 million parts, and the ability to use that in your technical publications directly is very valuable. We have faster performance now integrated with Teamcenter as well. And what you saw are some great new features, the carousel page object, the 360-degree publish. All of this is great stuff in Solid Edge 2021. This leads us, to, of course, to data management. As I say, you've generated a lot of data. Whether your company has 2 seats or 200 seats, we have you fully covered with our scalable data management solution. So let's take a look at the new concept modeling workflow using the popsicle mold. The concept modeler is a space where a designer can explore new ideas without committing the files to Teamcenter. It's a sandbox where you have the freedom to make any changes to a design without compromising the existing models. Here, we'll create 2 concepts of your design, of our design here. We can explore our first concept for the new mold retaining mechanism by removing some existing components and then making some changes to the mold plate, deleting features, as well as adding some new ones. Using the first concept as a starting spot, we can go ahead and create another one, which will be explored later. The designer has the freedom to create as many concepts as desired. With the concept 1 we can add appropriate mold retaining components to finish the first assembly concept. Going back to the cache assistant, we can switch the concept and open the design data. Here we can assemble the different mold retaining components for this idea. Once the concepts are finalized, the data can be sent to Teamcenter. The concept assistant helps with this process and provides options to filter for new or modified component, or even revert any changes that were made. The 3D Compare tool allows us to quickly visualize the changes between the concept and the server versions, and the user has full control over the actions for any modified component. Once everything is defined and the data from the desired concept is seamlessly sent back to Teamcenter. Also new in Solid Edge 2021 is the integration of Solid Edge model-based definition content. Now, with the downstream manufacturing information included in the MBD PDF output, is automatically captured by Teamcenter and visible within the item revision of the part assembly. In Solid Edge built-in data management, there's a new Open As command that allows users to control exactly how a file is opened from either Windows Explorer or from the most recently used menu. This allows full control over how an assembly is opened, such as defining the correct configuration, setting read-only status, applying large assembly options, and much, much more. There's a new shape search capability, allows designers more efficiently reuse existing models and prevent recreating designs from scratch. You can simply use an existing part or even model a basic representation, a basis of shape search. Solid Edge scans an available database for similar looking parts, and filters are available to approximate for a match criteria. Shape search results are compared to the original part in the accuracy and the size displayed, the percentage value. Once a desired part is found, a single click opens it in Solid Edge and makes it ready to use in our design. There's a lot of stuff there in data management. First up, there was Shape Search, a new product that allows you to reuse the data that you already have, and there's nothing more inefficient than recreating something you've already designed and built. But you've got hundreds or thousands of parts, or maybe even millions of parts, and how are you going to know where they are? Well, there's a way you're going to know this is through Shape Search. We've also enhanced Pack and Go, which is a very popular Solid Edge feature, allowing you to trace links even outside the current context. The Open As command is super handy, and it may not be super obvious at first. For example, if you want to open an assembly with a certain configuration, but you can do that easily from the file manager. This is good stuff for everyday use. Inside of Teamcenter, the concept modeler is really great new technology, such as being able to make changes to try out what-if scenarios without committing with the part number or deciding if it's a brand new part or just a revision of an existing part. Wire harness and alternate position assembly can now be visualized in the Teamcenter portal. And the local component support of Solid Edge is fully integrated into Teamcenter as well. Next up is cloud-based collaboration. More and more, we see our customers around the world having to collaborate acts across their businesses in different locations, collaborate with customers and suppliers. The cloud really enables this. There's really some very cool new capabilities in cloud-based collaboration. So let's take a look. Being browser-based means that you can use this on any device, your phone, your tablet PC, and it works with any common CAD file type, not just Solid Edge. It can be used with NX or any other common CAD file format or file format that you use within your company. Being browser-based means that it's instant on, and we can improve the productivity in terms of guidance. Here we've got a user-assisted guide that holds your hand each step of the way in using the capability of this app. Here, we're setting up a new project. It's guiding us to upload the files to this project into our cloud storage. We can do this in two ways, either directly into the browser or using desktop synchronization, which I'll show you in a minute. The data here could be PowerPoint, Word, PDFs. For CAD files, we've got an integrated 3D view environment. We can hide and show components in the tree on the right-hand side, and there's other great tools here too, such as Automatic Explode, where we can understand the assembly makeup. This is nice for manufacturing or design reviews, and no pre-setup explode needs to already be there. Also, it's great for tools such as the section views or cutaway views. If you want to take measurements on the fly, there's a tool here. Notice how easy the interface is, kind of what we call non-technical. So it's not just for design engineers. It could be, for example, used in a sales situation, and it's nice and easy to get to any of the product features. Here we're taking measurements. We'll take some measurements on the fly, and we can also change the units on the fly as well. And in this interface, you can also add markups or commentary. There's some tools to do some redlining. We can choose pre-selected shapes, or you can do some freehand sketching over the top of the 3D model, and we can include text annotations as well. And any of these markups get recorded in the tree. What's great about this is you can start a conversation back and forth about any of the issues you're tracking, whether it's positive sales points of the product or manufacturing difficulties or whatever you want to call out. It records them, this markup, and the time when it was made. I talked about this option of getting data into your cloud storage. We looked at upload into the browser. Also, what's available is desktop synchronization. So this multi-CAD project that we've got here on our desktop is represented simply as a folder. So any data we bring in to this multi-CAD folder, we can drag and drop it in here, or we can just save it right from Solid Edge. This will get synchronized in the background as you work in this app. Also, another great capability of this app is sharing with whomever you like. It's nice and easy. Just simply type the email address of the person you want to share it with. You can choose the access permission or the access level, or choose which one you want to grant. For example, here you may choose to view and download, or you can protect your intellectual property. Finally, augmented reality. This will take the 3D CAD model and superimpose it in this physical environment. You can snap onto any of the surfaces that you see through the camera and then scale it as needed. Then finger gestures can be used to manipulate the model. Here, the orange juicer really was that large, and it's a great use of augmented reality that get immediate design feedback. So we saw some great new stuff in cloud-based collaboration. Again, your organization has expanded, you have people in different places, you have customers and suppliers. Pulling that all together in this new cloud-based collaboration app allows you to synchronize files automatically because you can drag and drop them onto your desktop. Files will automatically be uploaded. You can view and you can do the view and markup like we saw. You can communicate with your customers or suppliers. And of course, it's all secure. You can share with whom you want to share with, but also keep your intellectual property very safe. Finally, augmented reality. You saw the ability to mix the physical world and the digital world with kind of a digital twin mix, if you like. It's very powerful. Customers are already using Solid Edge 2021. PJ Tolentino had this to say about it. He's really got a distributed design and manufacturing organization, and his ability to use the new cloud collaboration tools allows them to communicate and collaborate across the globe quickly and easily. And we think you'll find the same. I invite you to start your digital transformation journey. You've seen a lot of new features here in Solid Edge 2021. There's mechanical design, electrical design, technical publications, data management, a full set of tools. And I encourage you to start your digital transformation journey today, or if you've already started it, take the next step, integrate manufacturing or electrical, and the sky's really the limit. So what are some ways that you can actually get started on this? One way, the easiest way is to join the Solid Edge Community Forum. Just search Solid Edge Community or use the link on your screen where you can explore blogs, or you can go to the forum where you can learn from the knowledge base and interact with people who are in there every day. And we have an ask for you, and that's to help us bring Solid Edge education and community. We provide the Solid Edge product portfolio free to academic establishments and institutions and provide new learning assets and certifications. We really need your design expertise to join forces to help in the education and community areas. Finally, we talked about next generation cloud collaboration. An important point to make here is this is actually available right now. If you scan the QR code on your screen, go get the link, you can get involved right away. Solid Edge 2021, where today meets tomorrow.
Solid edge, model-based definition. I will be presenting some demonstrations as well as PowerPoints for you today. Model-based definition, it's been around for a while. Aerospace embraced it fairly early on because of the rigorous standards they need to adhere to. We can't have planes failing. The 3D model was always considered to be the correct answer. If there was any question on the manufacturing floor, you would need to go into the engineering department, and an engineer would refer to the 3D model. So a little difficult to access that because you had to actually go into the engineering department. Today, the story is a little bit different. Technology enables easy access in a controlled manner to your model-based definition via computers and networks and PDF technology and 3D viewing technology. So how does Solid Edge achieve that? Solid Edge has inside it product manufacturing information, PMI. It supports everything you need to create a representation very analogous to a paper drawing, but without going into the draft environment. So dimensions, annotations, your property text, section views, and the way views are captured, the analog to a drawing view on a paper drawing is a model view. So each model view can capture any dimensions or any GD&T or sections or whatever you want. And that information can be exported via JT, Jupiter Technology, owned by Siemens. JT is kind of it's a 3D format that can support many levels of detail. It can be a lightweight viewer only with metadata. You can have metadata and the full B representation of the model. So it's very flexible, very complete format. So downstream operations like Solid Edge Cam Pro and possibly other systems can consume that information without you having to interpret it via a paper drawing. It's also useful in technical pubs and also support for PDF, 3D PDF, HTML5. Now, a lot of this technology has been in Solid Edge for some time now, and you'll see what has been improved in the way of model-based definition. Now, synchronous modeling, if you've embraced it, then you already know this. If you haven't, then that's okay. But synchronous is really a perfect fit for MBD because the dimensions naturally are attached to the model edges instead of a sketch like you typically see in ordered modeling. That just makes it a natural fit for the model-based definition workflow. So there's no duplication of the dimensions, it reduces time. You're kind of achieving two things simultaneously. You're driving the model as well as annotating the model at the same time. So of course, any changes to the 3D dimensions are reflected in the part model. So very, very tight connection between the dimensions and the actual model. Now for you that are the users that are still working in the order, maybe that's the products that you design are more suited to that, and that's okay. Or if you just haven't made the leap, you can use the copy PMI in the ordered modeling environment to create an associative copy very quickly of those sketch dimensions, and they become PMI dimensions. You see they have a purple color, but what's kind of nice actually, because the PMI dimensions can be arranged more visually pleasing, more appropriately, and the driving dimensions, typically you're most interested in just simply driving the model. You're not really thinking about making it human readable. So it's kind of nice to actually have them separate. And you see that the tolerances also retrieve really nicely. So it's kind of one and done. You do it once in your sketch and you can very easily retrieve just the dimensions that you want for PMI use and model-based definition use. So now we'll do a short demonstration just showing some basic PMI modeling. All right, let's take a look at some PMI, product manufacturing information. We have it here in the assembly environment, and also if you edit into, maybe I'll open this part standalone. We also have PMI tab here as well. So we have a number of PMI dimensions here. So if you've worked with Synchronous, you might remember that dimensions that you put directly on the model actually become PMI dimensions naturally. In an ordered model, they can be migrated from the profile of the feature to PMI dimensions, and that's a really cool cool thing. So we have a couple of model views. Model views are analogous to drawing views. So you can right click and apply a view. Here's an isometric. So a couple of things notable. We have a feature control frame, and if we touch it, you'll see that all the datums highlight. That's because there's associativity. When the datum was created, they used this reference text, and now that's in drafting, and it's also supported in part modeling. So essentially it offers you all the other annotations that are in the drawing that would make sense for a feature control frame. And the bonus is, besides the fact that it sees all the associativity, if you ever make a change to one of these annotations, it's reflected in the feature control frame immediately. You might have noticed that change to a D. So you don't have to remember to go and update, and you don't have to take the extra time to go. So it's much better than manually typing in these datums into a datum control frame. So that's one thing. I'll go here and hide my PMIs. There's a really nice capability where if you touch a face, and you would just naturally notice this, I think, working in Synchronous, it exposes any dimensions that are attached to that face, which is great. But what you can do is also you can right click on one of these dimensions once you see it, and you can add it to a model view. So that's very convenient, or you can remove it from a model view. So you don't actually have to go find it here. If it's not displayed, that's just a natural behavior of the Synchronous modeling. One thing I noticed right off the bat is that these are just cylindrical cuts. They're not actual holes, which isn't probably the way I would do it. I like to have real holes with real data. Let's say I need to put a chamfer on there. I'm going to go up here and recognize holes. And I see that these three are found. And I'm going to turn those into a countersunk hole here. I'm going to use a 90 just as an example, with a 15 millimeter diameter for those dowel pins. Probably could do a chamfer too, but I'll just hit OK. So now when I go ahead and use Smart Dimension with the call out type, it's going to actually give me my feature call out as a PMI. So that's really pretty handy. I'll get square to this view. So to make a model view, it's super easy. PMI, you choose new view, and I'll call this pinholes. Looks pretty good. So it's going to capture the view and whatever PMIs are displayed at that point in time. So now, if I go ahead and look at my model views, I'll have one for pinholes. So if I apply my isometric, it takes me there. And if I apply my pinholes, it takes me there. So super easy. And remember, you can just touch a face. If I want to include this, I just add to model view, pick the pinholes, and it's added to it. I'm going to turn it on. This is a little ugly, so I'm going to move it. Maybe I'll put it down here. So now that will be part of the model view. And if I apply the view and apply the view, you can see it's just that easy. So that's the first demonstration, a little taste. We'll talk about publishing and the template editor in the next movie. Here we have really just a screenshot of the Solid Edge Cam Pro, which is built on Siemens NX platform. You can see that the feature control frames and datums all come through into the CAM system. It's actually pretty convenient that you can have those right there and turn them on and off without even having to have a paper drawing printed. And in this next demonstration, we'll take a look at that and you'll see how it works. This is the interoperability demonstration. You can transfer PMI data from Solid Edge models. It will happen through a PLM XML adapter if you just simply open a Solid Edge file directly. And there are some settings that will impact that as well. So you can see they all come in and they'll be collected in the PMI collector. And you can also open a JT document. JT document is a neutral format that can contain also other information besides just the geometry. And you'll see there's some options there for importing, nothing too unusual. And we'll just go ahead and open. And even though they don't display initially, they are also here in the PMI collector, and they're gathered into the model views, almost the same as Solid Edge model views. So if we double click the isometric, there's the PMI that we had in Solid Edge. Here's our top view. And so very, very similar, very good interoperability between Solid Edge Cam Pro and Solid Edge itself. Solid Edge continues to build on what's been in the product for a long time by adding MBD. Nice capability is the way that reference faces can be selected and attached to the call out, or in this case, a feature control frame. So you are sure as to just which geometry the annotation refers to. PMI is supported in STEP now as well for foreign export and import. And of course, PMI has more than just text. It's got data in it that can be leveraged in Solid Edge Cam Pro to help you manufacture your parts. So MBD is a set of tools that add on to Solid Edge, a little bit different than technical publications. Tech pubs are usually used for marketing and manuals, so they're a little richer, but this is a great way to create documentation for things like manufacturing. It is a purchasable upgrade for Solid Edge, and but it's very easy to use. We have a couple of buttons here for publishing and your template editor Publish is super simple, creates PDF or HTML5. Template editor is basically solid edge drafting with a few controls that are specific to PDF navigation. So no need to learn another application. They deliver some samples that you can use to get an idea, and you can create your own very easily. Add logos, headers, footers, adjust your sheet size, everything you'd expect to create a nice PDF output. Draw geometry, of course, use callout property text, text boxes, and you have a 3D control, a navigation carousel, a bomb view, and clear text. So they're licensed through the MBD. So, and when you publish, you have a number of settings. You can choose the model views, what the default view is, whether you want to attach the step, which is nice. If you're sending this outside for quote, maybe to be manufactured, you can include the step geometry for them to look at, and it will just be attached to the PDF. And it just simply opens afterwards if you have that checkbox checked. Model views are all supported, as you saw in the dialogue. The view orientation is all honored, thumbnails are created, parts list capability, user defined in the way of a user-defined table or a BOM table, and file attachments. Here's an example of how you can click on the carousel, and the bill of material is bi-directional for highlighting, very nice, just as you'd expect. Could also be a single part file in this example. Let's take a look at Solid Edge MBD. Maybe I'll go ahead and create a feature control frame. I've clearly run through this once before, but I have a true position to B. I've used the reference text, so it's going to be intelligent to the B datum. And remember, we talked about this reference geometry, so you can have more geometry than just the one. Roll up on that a little bit so you can see it better. Picking the cylindrical faces and then just accept, and then the face where I would like to attach my feature control frame. So if I get that done and I escape out of it, when I come back and pick it, you see not only is it highlighting the datum, but it's highlighting the faces as well. So it's very nice, and we'll add that to the model view all and hit OK. And go ahead and save that. So to publish it, it's super easy. You just click the publish button, but if you wanted to make a template or edit a template, you just click the template editor. And really it's Solid Edge Draft, except you have a number of extra controls here. You have a 3D view, carousel for navigation, your bill of material, table, generic table, and a text input field. So this is the one that I made a little bit earlier. So there's my 3D view. There's my BOM table. I don't think you need to see me kind of drawing these and organizing them. So there's a simple call out that I added, and a call out with property text. So very easy to use. I'll just choose to not save that, and I'll abandon the creation of my template. But right from Solid Edge now, I could choose publish template. My machining instructions template is the one that I want to use. So I just select that. I wanted to open the PDF, not interested in HTML right now. I think I want the all to be the default view, and we just choose publish. And we'll go ahead and overwrite that one that was there. Runs pretty quickly, and we should see a PDF open up with my custom template. So there we go. And if you use your navigation Down here, there's the clamp position, there's the slots, there's the awl, there's my my highlighting of the clamps and the stock. There's the actual part and a number of other views. So very easy to create MBD publications with Solid Edge 2021. So in the last demonstration, you saw a little of the section by planes with associative planes. Very easy to use, nice addition. They land in the planes collector found in your Pathfinder. You can see you can use multiple plane types. So these can be associative or non-associative. You can select which parts get cut. You can have multiple cut planes. Very nice. Center mark annotations in PMI, of course, just like you have in drafting. So we need that same functionality for model-based definition because we're essentially creating a paperless way of communicating the information. Supported in the 3D publish, of course, and you can dimension to them if you like. Bolt hole circles, yet another thing that we have typically had in drafting for a very long time, is now available also as a PMI annotation and can be inserted into your model views, just like in drafting, and also supported in exporting in the translators. Center lines, very similar, and well supported as well. Okay, so time for any questions. Hopefully, you all feel free to enter any questions anytime throughout the session. We have a question here. Can you really view PMI models with a free viewer? Yes. So using built-in data management or working unmanaged, that's a great solution. Maybe if you're running Team Center, the visualization tools within Team Center, probably a better solution there. Is there a web page we can use instead of PDF? So yeah, the Solid Edge portal, and what is it? Team Center Share is kind of the new going forward project that they're working on. Looks very interesting. Nothing but a web page, place to publish your content. In this segment, we'll look at mechanical design in a little bit more depth than we saw in the keynote presentation. So you could call this a little bit of a deep dive. I, again, am the presenter, Jason Titcomb, and this is our agenda. First, we'll look at a little bit of sheet metal enhancements, what's new in assembly, and some miscellaneous. First up is multi-edge flange. Great addition to the software if you use sheet metal. In the previous versions, you would end up with multiple flanges to achieve the same type of design if all the flanges were in fact the same. So this is a big time saver, and it's also a clutter preventer by gathering them all together in Pathfinder into one feature. So a lot less features. Also makes it very easy to edit. When you edit the parameters, it applies to all the edges that were selected when you created that initially. You can use it for a single flange. So if that's the if your flange is going to be rectangular and you're not going to modify the shape of the flange, that's probably the advantage of the old flange command. It has a little bit more control over some offsets from one edge or the other, and you can do a user-defined shape on that flange. So this is a rectangular type flange by default, but if that's what you need, this is very fast and very productive. But it is all very, very much like the older flange command that's been in the software. I'll show you this in the demonstration. Again, really easy. Select your edges. Can be a chain if they're all contiguous edges. And offset is supported as well. Corner treatment. Good example there. On the right, simply editing the options dialog as you'd expect with sheet metal design. And the ability to automatically trim if they intersect. So that is nothing more than a single click. And if any of the flanges intersect, it just automatically trims them. No guesswork, no clicking around. Just if they intersect, they get trimmed. Supports coplanar and non-coplanar, as you'll see in the demonstration. All right, notice I'm in the ordered mode. Multi-edge flange is right here. We'll just select the edges. You can easily hold the shift key down and deselect if you misclick, because we have radii at the corners. You see it's super easy to just play with your command bar like you're used to with the traditional flange command. Very easy to discover. If I want to extend inward, outward, or no extend, very easy. Angular dimensions, control all of them. And we'll go ahead and finish and run the command again. I want to show you how the intersection behaves in the automatic trimming. I'm just going to right click and move in. So whenever you have any intersections, it's a simple single click, super easy to do. Maybe we'll give it a little gap. Also super easy to use, and that pretty much covers it. Certainly change the angle after the fact, all parametrically driven completely editable. There you go. And we have one more short demonstration regarding multi-edge flange. Another small example of multi-edge flange command will grab an entire chain. This makes sense when there isn't a round break edge in between. And let's give this an angle of 135. So maybe 45. So the overlap is a little bit different than the previous part, but it works just as well. Just works as expected. Super easy. And we'll just, and then for another example, we could actually edit this, but let's just delete it and do another one fresh. Again, I'll use the chain and just right click. It'll come up 60 is fine. But this time we'll actually do 135. And if we would like to miter that, it's just a matter of one checkbox to turn on the mitering, and that is done. Next up, what's new in assembly design? Assembly internal components. So for Solid Edge 2021, they now support internal components embedded in the assembly file where there is no file on disk. A little bit of a mind bender at first. Data resides completely within the assembly file, so you could potentially have one file that is your assembly. You'll have an internal components collector, little folder-like object in your Pathfinder, compared with the legacy, you might say, traditional workflow where components are external and they are files on disk. And the assembly merely references those external files. So assembly files are typically very small. You'll have new icons for those internal components because, as you'll see, you could potentially have internal and external within the same assembly files. So it's nice to have a separate icon to remind you that's an internal component. How do you create them? It's done through the translator. There's a simple checkbox, and when checked, when you choose an assembly template, all the components will be created, but they'll be created as internal components instead of separate files. At first glance, it will look exactly the same until you notice you'll see the color difference. Great for supplier data. Typically, they're currently focusing on translation. Who knows where this might go in the future? It's a really cool concept. You can't, at this point, create them. It has to be done through the translator. So you can't do file new internal component or anything like that. But who knows where the future will be. Performance is a really major improvement, significant improvement with internal components. The speed, just the sheer speed of the importing. If you would like to eventually create external components, there's a publish internal components command. It then creates the files on disk. Structure is maintained. Choose your templates, where the files will land, and the materials applied. Conceivably, you could have both. You could publish a few for some reason. What is really amazing is that you can create assembly relationships to these internal components as if they were external components, and it will control the position of them. And also, you can do a mechanical analysis with the drag component command without having to have the external files. So this may be good for prototyping or just an initial concept or whatever you can imagine. So just really nice capability that's also available with internal components. And drafting. You can create a kind of a thin parts list because the files don't exist on disk. They don't really have a full set of property sets, but things like file name, your quantities, item numbering, those are available because they do exist within kind of the occurrence of the internal components. You can see what Solid Edge 2021 supports. Apparently exporting is coming soon. Interference analysis, that's awesome. Assembly relationships, the assistant. Hopefully you've all tried the assembly relationship assistant with foreign files. That's a great command to automatically create relationships for you. After all, it does just, you end up with traditional relationships when you're finished, so it makes sense that that would work. Motors animation, explode, very well supported. And now we'll do a quick little demonstration. Let's take a look at internal components. We'll just browse out to a Parasolid file that I have prepared. Of course, Solid Edge can open many foreign file types, and you would just want to notice that the options might be a little bit different for each foreign file type. Create internal components is the key setting that we need to have enabled to have this functionality of creating internal components, and then just go ahead and open and choose your template. Metric assembly is what I want, and just follow through with OK. You should enjoy much faster open times because it's not creating all these external files, but you see it looks very much like an assembly structure here. The icon color is a little bit different. If you right click, you certainly don't see file properties because the files don't exist except for this one ASM file, at least currently. You may want to use your assembly relationships. Currently, these components are just grounded in space, but this is a good opportunity to talk about some other functionality that isn't necessarily related to internal components, but just a little reminder. Don't forget about your assembly relationship manager. This is a great tool for analyzing relationships, maybe if you have a failed relationship or if you just want to manage them in a different perspective, the perspective from the relationships rather than the component. And I just used it to remove the ground. This wasn't actually really necessary, but just a good opportunity. Now, this is a great application for the Assembly Relationship Assistant, which will create relationships, especially good for foreign files because you typically don't get relationships. So I can select everything and go to my options and have it just create relationships about everything. And hit OK. Right click to accept. I'm only interested in creating mates and axials. So and they're pretty tight to each other, so the tolerance should be good. We'll just process. It finds these relationships and we'll accept and close. Again, a little reminder, not really part of the internal components, but just a great complement to it. So now we actually have assembly relationships on these components, and this can behave very much like an assembly without having to have those external files. You could do things like collision analysis, drag components. So very cool addition in Solid Edge 2021. I'm going to go ahead and save this assembly and just show you how you could, of course, make a drawing very quickly. Create drawing of active model. We'll use an ISO draft template, and because it's an assembly, it creates this ISO view if I don't use the drawing wizard, and even a parts list to some extent, because we don't have files with a lot of individual attributes like material yet, but we can still get a parts list of what we do know about these components. So that's really cool capability. And if you do want independent components, it's not a dead end. You can right click and publish these internal components. It's also available on the tools. Actually, if you ever do forget, you just come down here to your command finder and type your publish. So there's the publish internal components. You could run it from there as well. And this is a great opportunity to assign materials. And I'm just going to take the lazy approach and copy and paste that down through all of those. And it's just going to make independent files now. So we go ahead and hit publish. And you'll see this turn into what you would typically see as individual components. And we'll save that and make sure everything's all updated. And if we switch back to drafting, we should just be able to update those views as well. And we don't need the revisions. So there you go, internal components. 3D Find It by Cadence is a great addition to the software, very easy to use. You can use it from the Tools tab or right from within the Insert Component drop button, Insert Component from 3D Find It. You can specify the folder where the parts will land, and it's just really easy to use, and the website is really easy to discover. You have to create a login, and when the component is downloaded, it's just automatically inserted into the assembly, just like you dragged it in from your parts library. So super easy to use, great addition. Okay, let's take a look at using the insert component from 3D Find It. When you first launch it, you may want to log in. You can create a free account. You'll see there's a number of large tiles here, or you could use these buttons here at the top. We have an indexed search, a geometry search, which is super cool. We'll take a look at that later. You can actually draw some shape. I'll show you that. There's a little color search, or by primitive geometric shapes, or let's see, what else do we have? Parameters, we'll be using the text. There's also a function. So in this case, we need a cable gland. So we'll search for that. And we can append maybe our standard to narrow down our search. So we want an ISO standard cable gland. You see that there's a number of catalog suppliers over here. We'll just grab this one from ABB. Really nice viewer. The magic of modern web browsers and HTML5. You also have a 2D view, which is nice. Some of these, depending on the supplier, you'll have different results, different 2D views. There's a 3D. So if you want to know what configurable parameters they're actually referring to here for dimensions, if you're not quite sure, you can turn on this view to help you understand. So let's see, the chord range, for example, maybe we want to, that's a really big chord that goes through that, so we'll commit to that. There's a really nice, super easy to just discover and experiment with these. The grid view will help you be confident that you're picking just the right size. If ABB wasn't a supplier that you had access to, you could possibly go find similar parts. How similar would the match be? You can experiment with that. So I've narrowed this down to the SealCon, and I want I don't want an NPT. We want this metric. So once you found an alternative, you'll have this really cool ability to compare. In this case, I may want to look up by the thread. I know that's a pretty big hole, so it's a 47 millimeter hole, so we'll pick a 40 millimeter thread. And the comparison tool allows you to confidently compare your choices. And then once you're confident, you can just bring this down to solid edge. And we'll just use standard assembly techniques. We'll flip that over with the F key. Use our quick pick to get the front side and the face of our cabinet. Super easy. Let's see if we can find a grommet for that. So we'll insert component, the 3D find it. You could maybe a cable grommet might be a little closer. And pretty quickly assemble that using a couple of edges. This is an opportunity to look at the shape search. We happen to have a step file prepared here. You can see the file types that are supported. I'm going to broaden out the search a little bit. Let's add our standard in combination with the shape search. And this looks like a good match. We'll grab that. The clamp range is small. and we'll send it to Solid Edge. So this is pretty much the same. We'll get this a little closer. Next up, a little attention to the frame environment, adding weld gaps. That's been added in the global options and also right on the dialog, the ability to set a gap where the frame members meet each other. So apparently this is a thing. You want a little gap there. I'm suspecting it's for weld penetration or for shrinkage compensation because of the effect that the weld has on the joint. Nonetheless, it's been added to the software. The cut length is affected, of course. End caps for your frames. Some good examples in some images. We have a demonstration on this as well. Very easy to use, nice graphical dialogue. Everything you should need for your typical end cap for a frame, so you don't have that nasty open end of a steel tube. It can be safely capped off. It supports inward, outward, inset. They are reported in your parts list, different thickness values. It looks very thorough. I love these saved settings options that we're seeing in a lot of the dialogues, if not all of them, where once you have a certain set of preferences, maybe for one of your customers, you can give it a name and click save, or we'll save those presets out and you can recall them later to save time. Some examples of end caps that you can create. They show up in your reports in your drafting environment. And I have 3 demonstrations to show you. All right, let's take a look at the frame end cap command. We are in the frame environment, as you can see with the little close frame button proves that. Notice it shows up in our predictive toolbar also. It's always a great place to look first for the command, so you don't have to switch tabs. It's probably right there trying to predict what you might want to use next. I've gone ahead and run through this once before and used a saved setting. Just a little reminder that we have that capability, and we could individually select ends, or you can certainly fence select if there's an opportunity for that, and we'll apply. So that's probably the easiest, or maybe a common type of end cap. It's using the cross section of the frame to determine how big that should be. Notice it gets the corner treatment from the frame section. And if we wanted to deviate from that, it's simply a matter of unchecking that. We may want to do something like create an offset internally or externally. For example, if you wanted to create what would be a pad, like a foot, that would be easy to do. We'll do outward and we'll flip it. You see the icon change a little bit there, and we'll grab one of these cross sections and choose apply. So you see that's a really easy way to make a little foot. There's also the ability to do, if it's an inward, you can do an offset in from the end. Or you could see, you can discover these settings pretty easily. It will basically disable the settings that don't make sense. And it's really easy to discover and play with it. So there you go, frame end caps. So let's take a look at another really simple little example, just in case you're wondering if it's supported with patterning. We'll use pattern along curve. This is my favorite patterning command. It's so flexible. So we're going to pick the frame component. You see it all highlights with the foot. That's great. And we'll just grab this curve and right click. And the direction looks good, so we'll right click again. And I've run through this once before, so it's remembering my 6. And we finish in preview. So certainly frame end caps are pattern friendly, and they're also mirror friendly. We choose the mirror assembly command and choose our frame members and then our mirror plane. We get the typical dialog and completely supported in mirror command as well. So there you have it. Assembly, copy and paste. This is a little bit like, I think, what we had with capture fit for a single part, where once a part was placed and you needed to place it again, or you thought you needed to place it again, you could capture that information. And if you recall, you had the option of persisting it right in the part or just having it in memory for use in the same design or other components. So this is similar to that, except it allows you to copy multiple components and subassemblies, and all the internal relationships will be captured, of course, and then any dangling relationships that need to be replaced on the new target when you paste it will be available in the top view. And you can skip certain relationships if you're not quite sure if you need them, or if you have a different plan for them in the destination assembly, so you have that control to just ignore them, and you'll have a relationship status for your convenience. So this is kind of the workflow. I think the best way is to see this in the demonstration. So the internal relationships are in the lower area, and the external relationships that need to be satisfied are in the upper area. So let's jump into a demonstration. All right, let's take a look at copy and paste capabilities in Solid Edge 2021. This is a really nice enhancement, super easy to use. Here we have a design that we've built previously, and we think that we can reuse some of these components on our new design, which would be here. And they essentially will cover up the mechanicals on the left and the right side. So normally you would go and use the typical place part. You could certainly use copy and paste like we used to, but this has been much improved now. So we select just the components that we want and just plain old copy. Control C on the clipboard if you like. And then we switch over to our other part. This could be all within the same assembly, or it could even be separate assemblies. Now, instead of pasting with the button, which will work, the components drop where the mouse pointer is. So I really prefer placing my mouse on the screen at a convenient location and then do Control V. And when you do that, you'll be presented with a new dialog that's going to show you all the learned relationships. So all the relationships that it found in the existing design, and you're free to examine those, hover them, understand them. Maybe there are some that you'd like to exclude. You can uncheck the checkbox, we'll exclude them. So there may be a use case there. You may get to one at some point in the process and you think, oh, well, I don't really have a hole for that yet. So you can just slip over here and uncheck the checkbox, and it will skip it and move on to the next one, and then you can finish up later. But some of these are internal, meaning, so for example, the screws are actually mated and axialed to the actual sheet metal part. So those are internal to what we are pasting. So this is kind of a better view of what you're actually going to do. The external relationships are ones that aren't within the selected files. We need to basically find new destinations for them. So it will by default work right down from the top. It'll show you your list of internal relationships as well. If at some point you wanted to just abandon this and go to a manual assembly method, you could do that. You could turn off the dialog if you're very comfortable and you don't need to see the progression. You could turn the dialog off, or you could turn it back on at any time. But you see, we're getting the hint of the face that we should go find a destination for. So we simply select that top face. So this is very much like the workflow if you taught a part with capture fit, except it's kind of taken to the next level. And now it's moved on to the other components where it wants the side for a planer. And then there's a little green edge highlighted right there. So that's going to coincide with a planar alignment to the back face. And then another planar alignment up at the top. Again, if you didn't have a face, you weren't quite sure what you wanted to do, you could just uncheck that relationship. In this case, it's super easy just to pick that, and then the dialog dismisses, and what you're left with is just traditional assembly relationships. And you see, if we select one of the screws, that all the internal relationships were maintained. You see it's the screw is associated with the PSM file that was brought along. So there you go. Really easy to use and powerful new copy and paste capabilities in Solid Edge 2021. So the ability to locate parts that are not active has been added in Solid Edge 2021. There is a button to activate it. So essentially the need to activate parts as you work has been reduced. Still have the improved performance through memory, lower memory usage, but much improved usability by reducing the need to activate parts. So how they achieve this magic, I don't know, but it's nice. There is a user preference. There is a push button right in the interface. You can, if you decide you prefer the old functionality where only parts that were deliberately activated would be locatable, which is perfectly valid if you like that, and you can turn that off globally in the options. And you see we have a list here of what is supported for location. We have a few miscellaneous topics. Adaptive user interface, very cool. Give it a try. It resides just above your drawing window. It's predictive, uses machine learning, tries to predict what you would want to use next. If you want to change the behavior or turn it off completely, there's options in the options dialog. And decals, super nice addition. This was a little bit steppy to do this kind of thing before, so a dedicated command has been created. You simply select the command, select the image, select the plane, project to faces. Super easy to use, kind of an ordered workflow, and we'll give you a quick little demonstration of that coming up now. Okay, let's put a decal on this part. Decal command is right here. We're in the ordered environment. Pick a plane, browse out to my image. Got a variety of file types I can pick. I'm going to use the transparent color that's right in the file. Choose OK. We'll resize it. And then drag it, place it. And a little bit smaller. Geometric relationships completely supported. Dimensions. Close the sketch. Select your targets. Right click. Adjust with dimensions. Super easy to use. Deviation analysis. If you are using reverse engineering and modeling scan data, and you'd like to compare between the scan data and your resulting model, then I think you'll like this tool. The comparison can be made between BREP and mesh, or two mesh models. It's a point-by-point comparison of the two objects. They can be design, construction, surface, and mesh bodies can be STL or JT, obviously. The UI is very straightforward. We have settings, you have reference object selection and test objects. So you just simply need to select two objects, and in the results, you'll have a max, min, deviation, and you have control over the color bar, the precision, the tolerance, results information, all covered pretty well in the demonstration. Very similar to simulation stress analysis, except the red in this case means, higher deviation between the two objects that you're comparing. And an improvement to KeyShot. KeyShot now has a denoise option. One click, CPU, GPU support, eliminate the noise in real-time view. Very nice, just much nicer. And the ability to add cloth and fuzz material to your design. Very nice. Okay, decided to skip the deviation analysis demonstration at the last minute, running a little late. Maybe we can provide that later. It's actually pretty easy to use once you've seen the slides. So we do have a question that came in. Multi-edge flange transition to sync. Yeah, so what happens when you do that, if you right click and move to synchronous, it explodes it into individual flanges. So that particular feature type doesn't migrate directly to synchronous. So a little bit different. And there was another one. Synchronous mode, yeah, so decals in synchronous mode. Can you have decals in synchronous mode? Well, yeah, you can do it in either mode. It's kind of an ordered workflow. That's really the best way to describe it, but it works in either one. Can you do the same thing with two parts that were created directly in Solid Edge? Yeah, we have model compare. But this is mostly for mesh models. So there is a model compare now in Solid Edge, which is kind of a different. It's more for a model where you have a BREP, a boundary, you have faces and edges and cylinders. That was more geared towards mesh models. Mesh against BREP, I guess, is probably what it's typically used for. That's what I would say. Next up, solid edge simulation, or embedded FEA. Digitally validate your designs. I'll be your presenter today. The meshing capability within Solid Edge is based on FEMAP meshing technology. So it's a well-proven technology. You have quite a bit of control over the mesh, such as localized mesh control, face by face or edge by edge, or also very easy to use defaults where it can automatically determine the best mesh size for your model. Geometry-based constraints and loads. The graphical handles provide easy editing and orientation for vectors or editing parameters. The quick bar floats in the screen just like other commands within Solid Edge, so it's a very familiar interface. The solver is based on Nastran, another proven industry standard for a variety of analysis types. The post-processing is quite rich, includes animation, of course, color contours, probing. You'll see some of this in the demonstration to follow, displacement and report generation. Synchronous technology is a natural fit for the embedded FEA. Super easy to create multiple studies, jump back to your modeling commands, make edits, and iterate very quickly to find the optimal design. Regardless of whether you're doing a static or thermal study, the interface is very consistent and very easy to use. You get a consistent feedback in your study pathfinder, gives you indications on what steps need to be completed before you can complete the simulation. The ribbon across the top of the screen is a very logical flow from left to right. And it only provides you with the commands that make sense for the type of study while you're doing that study. While the whole time leveraging the FEMAP and the Nastran underlying. So bottom line, very easy to use, familiar solid edge interface, very good integration, but built on top of FEMAP and Nastran. Beam studies for a frame design. Because the frame environment offers so much information, you can get very fast solve times because many things are automated, such as connections and things like that. Linear statics for more complex analysis for stress and displacement. You'll see this in the demonstration also. And buckling analysis for very thin parts with an axial load. You want to determine at what point they'll buckle out. So for support beams and thermal studies. Solid edge supports steady state heat transfer, can also be used in conjunction with buckling and lithostatic. Transient heat transfer. And we have a really fun demonstration. All right, let's take a look at solid edge in action. Solid edge simulation. So let's apply a display configuration for just the frame components. We'll jump into the frame environment. So when you perform a simulation in the frame environment, you create a new study, and the default is beam, because it knows we're in the frame environment. So you can simply select all, or of course pick just the components that you want to analyze. And we'll just first define a force. We want it way out on the tip, so we'll use node. And this should be, I believe, 2.5 tons. And we'll flip it to be pointing down. And to constrain the members, we'll use node and pick the ends where the wheels are. So that's right where it meets the floor, you might say. And then we'll use a pinned constraint, because pin constraints allow rotation freedom, which it will be more accurate. And we want to use these nodes down here. Whoops, pinned constraint. And we'll pick node, and we have 3 at the base of these support members. And there's another one. So there we go. So we're ready to jump into the mesh. In this case, it's a very simple mesh. The defaults should be fine. We should be able to just do a mesh and solve. You have a separate solve button if you wanted to, and it takes us right into the results view. We'll talk a little bit more about this results view later. By default, we're seeing stress. You can also look at displacement. This is a nice model because this actual visible displacement, if you use the actual movement and we animate it, sometimes the stresses cause so little movement in the design that you can't even see it move. So this is nice. This is 15 millimeters of actual displacement that you would see. And that's probably fine. If we switch back to stress, one might think, well, these uprights look a little beefy. They're well within the limits. Maybe we can use thinner material. Let's take a look at that. I probably want to turn the mesh off. Sometimes I'll just poke the mesh button and turn that off. You have control here in Path Study Navigator as well. So you have control over individual component meshes. You can turn those off and on, which is nice. If you have internal components, you want to see what's going on. And the results set shows here. You can see there's another study. You can have multiple studies. We don't actually need that other study, so we'll just delete that one. So that's Study Navigator. But these members, we think they're a little heavy. So this is a nice example of being able to work right within the Solid Edge environment without having to jump out to another software to do your analysis. So that's a smaller member, and then we'll do the same again here. make that a 30 millimeter round tube. And then it's really just a matter of poking the solve button again. And it remembers everything else that we've done, and it remeshes because the geometry changed. And you can see we're pushing the envelope a little bit on the thickness of these tubes, but we think it'll be good, and it'll be a little bit of a cost savings. So that's a good start. Let's close out of the simulation results. And I'm actually going to close right out of frame and go back to standard assembly. We have another display config that is the leveler. So the leveler, so the leveler is it's a screw device that moves the support point. So it hangs from here from a chain, and then you have a couple of chains that run down to your engine. And if the engine center of gravity is off too bad, you can basically move the hang point so you can level the engine and get it right into your engine compartment. But this is a cool opportunity to look at other simulation geometry. Because these are sheet metal components, you can use the mid-surface. So mid-surface has the benefit of performing better and sometimes producing a better, more accurate result. And this is just a nice example of using that. And then we can hide these components. I'm just going to tap the space bar to allow me to select multiple items and hide those. So you see we just have these little purple surfaces, but the simulation works very well with those. So now we'll go ahead and do a new study, structural steel, but we're going to choose mixed and general bodies because we're using those mid surfaces. We'll choose OK. I'm actually going to select deliberately the components, and let's take a look at the section so you can see what's going on here. We've made a couple of flats on the rollers. These little rollers normally roll along the bottom. It allows you to crank that crank and have it actually move position. So we didn't want just a tangent contact point. We wanted a more substantial flat. So there's a little bit of modeling that was done there, just so you know. And Control D turns the clipping off. So back to simulation. We'll go ahead and we can do our forces now. It's pretty flexible. We need to create some connections between these individual components. You can do manual connections, bolted connections if you have bolts. The auto connection is really awesome. It can just find span gaps, you might say, and then I'll say select all, which finds all the components that were defined in geometry, and it should find all those connections. In this case, we have 8, and it will just create those connectors for us, and so we don't have to manually create them, which you could do. And they show up in the collector here in the Study Navigator. And then I like to do a mesh right up front, just to make sure, in case I need to modify the geometry. Sometimes there's little pieces of geometry that are pesky, small sliver faces, things like that. There's actually a cool option here that can automatically prepare your geometry for meshing. So what it will do is find these small sliver faces that are really just going to be annoying for the simulation software and insignificant to the results, and just remove those. So we don't need that because we have a simple model, and it's just going to add extra time, and we can just mesh that. And if you want to improve, if you want to redefine the mesh to be a little finer, it's a simple slider to do that. That may be a little finer than we need. That looks pretty good. So let's define our forces. I'm going to use the edge. Remember, that's a little surface geometry that we're selecting there. Same load as we had before. And we'll do a fixed constraint here. Let's see, I'll do feature because there's actually a little Boolean feature in there where we made the flats. And you have nice control over the size of the indicators. Sometimes they're a little big on a small face like that. So that looks pretty good. Let's go back to meshing. And I'm going to choose not to show the mesh and then just do mesh and solve. And this is very similar to what we just saw. It's going to complete the solve and then take us right into the results view kind of automatically. Very dramatic results view, a 10% exaggeration. We can look at stress or displacement. Again, actual displacement works really well here. There's the things like a maximum marker. You can probe individual nodes, probe individual edges. I'm actually going to show you a little bit more about that later in another demonstration. And we'll do a report a little bit later. But let's, so we've got quite a bit of deflection here. We're a little uncomfortable with that. We want to do one or two things. We want to either shorten the var, which would be unfortunate, or we increase the thickness of this member. So I just did control space bar, by the way, and I'm going to reach into this part, and this was made in synchronous modeling, so we have quick access to. So let's say maybe 600 per length. And then maybe a 3 millimeter thickness. And then we could analyze that again. And then you could spend all day doing this until you finally found the one that is optimal. Well, Solid Edge has the ability to create an optimization and do that bulk work for you. You simply create new optimization to find the objective. In this case, we might say, well, we only want 1 millimeter of deflection out there. So let's shoot for that as an objective. And then the design limits, we don't want to exceed maybe von Mises of 190, I think has worked well for me in experimenting with this. And the variables that we're going to push around to see what the best solution is the two variables that we just modified a minute ago. So we're using peer variables and simply selecting the two that we want. Notice there's a range. That's just standard variable table technology that's been in the software for a little while now, but it gets picked up by the simulation software. So it's going to work within that range to find all the possible solutions, and it's going to try 10 times. You could change that value certainly, and then the convergent parameters controlled, when it's done. Essentially, is kind of the way you would think of it. And I like to save it. You could definitely hit optimize, but if you save it, you can come over here and you can maybe do some more work, but then you can do multiple optimizations, but you can just right click and optimize. So this is going to run through a maximum of 10 iterations, only stopping if it encounters an error with one of the configurations in length and thickness. And if we watch closely, we should be able to see the length and the thickness actually change a little bit as it adjusts and tries different sizes, producing results for each iteration. It's very similar to what we've done where we end up with a results view, except you'll have a complete series of results views. So you could go and interrogate each one and kind of just visually compare each one as a human, laying eyes on each one, or you can use the Excel spreadsheet that it produces to look at the numbers and decide which is probably the best for your application. So there may be materials availability, there may be weight concerns, things like that, or we want the length of this to be long enough so it can handle large motors, but yet we want it to be stiff enough so it doesn't deflect enough, so the bearings maybe get a little unstable, but yet we don't want to overbuild it either. It would be really easy just to completely overbuild this whole thing, except it would be really heavy. Shipping costs, material costs, and just the annoyance of moving around such a heavy piece of machinery. So we're getting near the end here. One more to go. Actually pretty fast, I believe. This is the kind of thing on a larger assembly you might let run over your lunch hour, or you run a few iterations to make sure it's going to work okay, and then let it run all night. And in the morning, you'll have some nice options to take a look at. All right, so there's the summary. That'll give that a second to create that Excel spreadsheet, and it should bring it up. Here we go. So again, you can scroll through here and examine the values. Looks like 750 millimeters in length with a 6 millimeter. You can decide. And we have some what's new in simulation for Solid Edge 2021. Improvements for highlighting simulation properties that are required. This is a really nice little enhancement. It's going to highlight the things like density, modulus, yield stress, things that are required to get a successful simulation. And if you create a couple study, such as steady state heat transfer and static, they're both highlighted. So, and we have a short demonstration for that. Here is a small but very nice enhancement in Solid Edge 2021. If we take a look at our simulation, and maybe you've encountered this, if you attempt to solve, the solve cannot complete because Poisson's ratio and possibly other bits of information are not set properly in the material table. So if we double click our material table, this could be because you're using a legacy material table that you've been bringing forward. So there's a nice little toggle here that in the darker green, we have the information that is required for this type of linear static simulation that we're trying to perform. And then in the lighter color, we have other information that may be useful for other types of studies. So maybe you should fill that in as well. So you see the density is 0, the thermal expansion is 0, Poisson's ratio is 0. So this is a little toggle here, and it is sticky. So if you turn it on, it will stay on. And then you would just need to fill in that information. In this case, I think I'm just going to go and pick a different material and apply that to the model. So I think we need to move on. So we're going to, there's a little bit more about what's new. Edge selection and what was the, being able to remove components. So maybe look for some movies that might cover that a little bit more detailed. We're just running a little short on time. So a little bit of a Q&A. Definitely want to answer any questions. Somebody, let's see, can advanced simulation license be checked out when I'm not using it, or checked in rather? Yes. So there was different levels of the simulation solution, and the most advanced one, it's nice to be able to check that back in when you're not using it, but continue to use Solid Edge. Simulation in different materials. Let's see, can I simulate for a different material than the part is made of? Yes. Next up, manufacturing related topics. I'm your presenter, and this is what we'll cover. First off, additive manufacturing. Just to showcase what is available in the software, new preparation tools, new validation tools for wall thickness and overhang, the ability to create physical threads is very useful for additive manufacturing. We've always supported cosmetic threads, but you can now convert those to physical threads if you like. It's a really great capability. You can toggle from cosmetic to physical and then back to cosmetic if you want to when you're finished printing. Wall thickness calculation, super easy to use. I'll show you this in the demonstration. You want to validate before you spend all that time in material 3D printing. If you hover over a face, you'll get a value for the thickness. Apparently, this is a very common failure point for 3D prints, according to the service bureaus. Overhang is a common problem with certain types of printing, and we have validation tools for that. So you might rethink how you're orienting in the print bed, or rethink your design possibly. And internal voids are also have their own issues, especially with a powder bed machine. You'll end up with material enclosed in there or captured in there, and you really don't want that. So the software will detect internal voids for you. And the ability to reorient the 3D model in your print zone, super handy. I'll show you that in the demonstration, especially when you're overcoming your overhang problems. We can import OBJ files now and work with those, multiple or single mesh, and export OBJ files as well. Some 3D printers like those file types. You can now also assign a specific print material. I'll show you that in the demonstration. It can be different from the material assigned to the model, which is sometimes the case if you're doing a prototype. Super easy to do. Open the material table. And there's a really nice validation tool that can kind of combine these tools for you, that you can do, you know, combines the overhang, the wall thickness, and also some of the things like non-manifold regions. Very nice kind of a final check before you go and submit that to a bureau or send it off to your printer. And really great addition to the software. It's converted to STL in the background, depending on your settings for coarse or fine. So here's a cool little part. If I wanted to 3D print this, I may want these big threads to have physical threads. They're pretty good size, so we could use the physical threads command here. You get a little bit of a warning that, you know, this could be a graphical performance issue if you have many of these and you consume them in an assembly. So you'd want to simplify them, or you know, just think about whether you want to use them or not. And you can switch them back. If you go back here to your thread definition, you can just toggle that off, and now you have just a cosmetic thread. So you have ultimate control over that. Wall thickness, very common issue. And if we want, this is a big part, so I want at least 0.5 thickness, and we'll examine that. So these areas are a little thin. The top's barely over 1/2 inch, I think, so we won't worry about that. Overhang is an issue depending on how you orient it in your build area. So if this is a pretty serious overhang, if this is going to be considered my floor, the hole will be okay. So that's fine. And set the print. If we want to set the print material, that's just a matter of one button, choose the material, and hit OK. And so that would be available downstream or for reference if you were to hand this file off to someone else. And if you wanted to see how to add that material, it's pretty well documented, but if you go into your material table, we should have some non-metals, plastics, ABS. So you see I've just added a custom property in here and set it to yes. It's just a text type. Real easy to do. So we'll look at the print validation in a second, but let's orient this for optimal. Let's do a rotate. Okay. 90 degrees, lay it flat, pretty good. So check this out. When you cancel, it restores the model. It doesn't actually rotate the model. It does it kind of in the background, which is really kind of nice, because now when I check the overhang, it's going to use whatever I did. So now I just have these little flat faces in the back to deal with if I orient it that way. And synchronous modeling can deal with that. We'll just select the face, position the steering wheel, and tip it. If you have the design freedom to do this, it's a great way to avoid these overhangs, and it's crazy fast with the synchronous technology. This thing was also a little thin, if you recall. So again, synchronous wins the day. I'll give this a 0.4 because it needed to be at least a 1/2 inch thick. Did I do that right? I think I did. Yep. It doesn't really matter. You get the point. Super easy to make edits with the synchronous modeling. And then when you're all ready to go, you can run your print validation. So this is kind of a tool that gathers these things together, the wall thickness, the overhang, adds things like non-manifold, and you can just compute that. And it finds all our regions for us. And so you see that we fixed the wall thickness. So there you go, a little 3D printing. Next up, solid edge 2D nesting. We see a variety of parts manufactured out of sheet goods, sheet metal, sheet plywood, variety of components. If you would imagine just 3 simple shapes like this, how you would really optimize your material, manual placement might look like this on the left, but a software may come up with a better solution to tightly pack those in. You'll have less waste. You see across the bottom, there are these little extra pieces that won't be good for anything when you're done. So software wins. Now, when you really get into complex shapes, that's where the algorithm really shines. It can do a much better job than the human can do. The shapes that are nested are actually 2D shapes. So these can be obtained from the solid edge models, but you do need 2D shapes. Essentially, the software extracts them to a 2D from the flat pattern. So it's a very powerful algorithm. Automatically extracts the flat from your solid edge models. It also can import neutral formats if you have some legacy data. And the occurrence quantities, if you do open your solid edge assembly, it can glean the occurrence quantities from the assembly. And there's a job multiplier if you want to run more than one set. That is good to know for the algorithm, because it may find a more efficient way to do that if it knows it has to make 10 sets. And there's a great cost estimator also, so, and a detailed report at the end. So here's a little bit what the interface looks like. Multiple sheet sizes. I'm going to show you all this in the demonstration. So it could be potentially very high return on investment with the software if you start to calculate the material costs and the amount of waste that you may have. Even internal areas that you might not think to use. So if you have a cutout in a part and you want to fill it with some smaller parts, the software is smart enough to do that. Adding spacing, of course. And you can, as I said, you can just simply open an assembly file and it will go find all the parts or sheet metal parts that are appropriate for use in the software. It will then gather up your materials so you can process one sheet at a time, one material, one thickness. And it, as I said, it will glean all the part counts, and you can very easily multiply them to up your quantities. Very productive. Cost estimator is super simple. Just give it a value for the cost per square meter, for example, and it knows all the square inches and it can give that to you. And there's a report output about everything that happened during the whole process, so you can verify if something got skipped for some reason, or do whatever you want with that log. So now we have a nice little demonstration that's going to go into that all in detail. Solid Edge Cam Pro is up next. Really nice improvements in the user interface. The dialogues now are an Explorer style dialogue. If you want, you can convert old dialogues to be that new style. Very easy to navigate. There's actually now a search field at the top that I'll show you in the demonstration. Really great improvement. Chamfer milling has been added. It's a very common type of operation, so they created an operation type specifically for that, for prismatic parts. Associative, of course. And the in-scene selection is very powerful. It's always been very powerful, but now it's much easier to discover and use using the pop-up in scene. I'll show you that in the demonstration. Very verbose tooltips as you hover over the controls to help you understand what those settings are for, to avoid too many trips to the help documentation as a new user gets started. High-speed machining technology included, no extra charge. World-class technology now includes bottom-up cutting and safe pillar removal. I'll show you a little bit of that. It's very cool. All right, let's take a look at Solid Edge Cam Pro. We saw this part earlier in a demonstration. We're going to send this over to Cam Pro for machining. I had Cam Pro open, but it will open it for you if needed. You get a dialog that gives you an indication if you've added any components, if anything's changed, but this is how the interoperability between the two softwares work, so that you're able to go back and change your Solid Edge design and then just push it over to Cam Pro, and it will update the tool paths without you having to reselect any geometry. So we'll initialize this for manufacturing. We can just click the manufacturing button. In this case, I have a template that I'm going to use. It's kind of my preferred template. There are a number delivered with the software. So what that brought in was a XY0, super easy to just double click that and position it for 0.10 millimeter clearance plane. Looks pretty good. Define the workpiece. That's just my part material, and the blank can be a piece of geometry. If you have one, it can be offset from the part, or in this case, I think a bounding block will probably work pretty well. So we'll go with that because it's easy. We'll show you a little bit more later. Check geometry is great. You can see that the icon looks a little bit like a clamp. So you can select geometry that you want to make sure the software doesn't cut into. And that's check geometry. You can select your material if you like. And then you see in the operation navigator, this came in from my template. If I go to my machine tool view, we have a number of tools that came in from my favorite template. I have a 14 millimeter end mill, and let's go ahead and create an operation. So we have a number of pallets to default and my template. I'm going to grab the adaptive milling from my template and use a 14 millimeter end mill. We want to cut the workpiece, and we probably want to semi-finish it. Just that easy. So at this point, we have defined everything that we need to cut, and we should be able to just generate that tool path. This is going to be a very greedy operation. It's going to use the adaptive toolpath strategy. You see it identifies the closed areas and approaches them differently in a helical pattern. You have complete control over that, and the open areas are approached a little bit differently. The verify, you have a couple of modes. You can use 3D dynamic. You can actually, anytime you see the toolpath on the screen, you can poke, and I'll show you that. Sometimes I like to jump over here to turn off the part. You'll see in a second why. It just gives a nicer, cleaner display versus the, you get that what they call Z fighting in the computer graphics world, where two parts collide. They have no material on the top face. So that was easy. We've roughed that part out, and we probably could go ahead and finish with, let's just finish with the same tool. I'll do an operation. We'll grab one from the standard palette, maybe. You can see there's a number of, what do we have? We have facing, we have floor and wall, pocket milling, wall without floor. That actually looks interesting. I love these tool tips. They give you a lot of good information. Everything else looks good except we're going to go for a finish operation. And all we need to do is we want to specify the wall geometry. And I'm going to use my in-scene filter here and choose adjacent faces and pick the bottom face. So that grabs all those side faces for me in one click. And we can go ahead and generate that. We should see that it only cuts where it finds material because we've used the 3D IPW technique. And just hit OK. Looks pretty good. And we'll finish up with chamfer tool. So we'll create an operation. Let's see, my template. I have a chamfer milling that I've perfected in my template. And we have another opportunity to use the awesome selection filters that we have here. So we'll choose tangent faces. 1, 2, 3, 4, 5, 6 pockets. Hit OK. The lead in, lead out, non-cutting move. If you want to make changes to that, you can simply jump over here. I really like the, so for an open area, I think I'd like a, have it linear engage. Let's see how that looks. So there we go. Nice, simple chamfer operation. Solid Edge Cam Pro has what's called an in-process workpiece that is just naturally transferred from one operation to the next within a sequence of machining operations, but it also can be transferred to another vise or even another complete separate file and job. The simulation is very nice. I'll show you some of this in the demonstration. There's a heat map kind of that you can turn on to see where the bulk of your remaining material is. A variety of ways to show your tool path and analyze the tool path. Find uncut areas. I'll show you some of that in the demonstration. And G-code based simulation. Solid Edge Cam Pro can do both internal calculated path if you don't have that completely set up, or if you have, it will post the G-code and then read that G-code back in and drive your machine tool based on that. So if you're developing a post processor, that can be very valuable, or as machines get complicated, sometimes there can be more unexpected behavior. There are custom kits that you can purchase, and there's a bunch delivered with the software. You can have Maya develop them for you, or you can develop them yourself. And multi-axis roughing is newcomer to the software. Very advanced bulk material removal operation. We won't do a deep dive on that, but you'll get a chance to see it, and we'll show it in combination with the verification. Let's take a quick look at the integrated simulation and verification. We saw verification a little bit. You can verify using the entire machine tool. You see here we have kind of a complex machine and a kind of a complex aerospace type part. We have a multi-axis roughing operation, and we're going to jump into the integrated simulation and verification. It takes just a moment because it's actually posting the code in the background, because it's going to use the actual G code that's posted for the verification. So we'll turn on the execution view. This gives us our display of the actual code and at what point in the code the machine is at. I've turned on toolpath display. You see the toolpath is there. You can have that on and off anytime you want. We're going to check for machine collisions, and we want to see the material removal. So at this point, we can just go ahead and play. And if we kind of get in here a little bit, we can see we have the full motion of the machine displayed. The code is being read line by line. Things are really tight with this operation. I expect that we'll have some collision issues. We may need to extend this tool. So right there, we have a collision of the head. It's fairly obvious, but this is a great opportunity to show you how you can just stop. And we can go to the machine status. And this is really nice. It allows you to just kind of maybe experiment and kind of just grab onto the table or any axis that you want and maybe rethink your approach vectors. And we can see that stopped at line 1907. So you can just click and put a breakpoint there for next time, and you can run that through again. It'll stop at that breakpoint. So very cool integrated simulation and verification. Next up, post-processing. New capabilities in post-processing, the addition of Post Configurator. I'll show you a little bit of that in the next demonstration. Supports multi-channel, very advanced machines. Faster post-processing for 3-axis tool paths via the turbo mode. And very nice end user interface for modifying posts. You can actually get one to try from the Post Hub, kind of a central portal for downloading quite a few free posts and some that are also more advanced and that you may have to pay for. So it's searchable, sortable by controller family, and very easy to just try one out right from within the interface of the software. And I'll show you that in this next demonstration. So at this point, we might think about post-processing. So you just simply select probably your program node, unless you're just testing one operation at a time. When you're ready to post the whole program, there's a cool Post Hub tool. So the first time you'll probably be asked to log in if you haven't already. I've already logged in and it's remembered me. So I may be interested in, let's say, FANUC. Apply that filter and search. Maybe just 3 axes. And they've nicely labeled the ones that are free, so you can make modifications if you want. And then you pick the one that you want. There's a little information button, and there's some documentation usually. And you can just simply download it. And when you do, you'll be asked if you want to just try it or if you want to actually install it. So it's very cool. So I've actually gone ahead and installed this 13i, and we'll just post to it. Obviously, I've run it through once before. I chose to install it when I clicked the download because I have write access to the post directory. So a lot of toolpath with that adaptive. I noticed right out of the gate that it's using an R instead of IJ for the circular moves, and I thought I'd show you how easy it is to handle that. So we'll go into our post configurator. We're just going to choose our post that we want to edit, and I'm going to go up here and just type in arc and ARC output mode. And right here, there's a nice little question mark that can help you even further. We're going to say circular move always for IJ. We'll say on and save it. You can actually just post it right from here if you want to fiddle with it and examine the output, but we'll just choose OK and we'll post. And I'm going to list the output again. And there we go. And look at that. We got I's and J's. Very easy to make modifications and try out post processors. So there you go. Okay. We're a little over, but what do we have for questions? There was a question about simulation. Is simulation in Classic?
It is just Simulation Express for single parts and sheet metal files.
Yeah. Okay, so yeah, single parts and sheet metal only. There's a few different levels of simulation. Let's see, do we need to have Solid Edge? Do I need to have Solid Edge on the same machine as CamPro to open the files? Negative. And do the versions of Solid Edge and CamPro need to match exactly? That's also not a requirement. It has to be pretty close without getting into the details, but they have a nice way to maintain the associativity between the CamPro and your Solid Edge if they slightly mismatch. So I think we'll do the final poll. Really great that people are hanging in there. This is a pretty long event. Really appreciate your attendance and even giving us some great feedback with the poll questions, just so we can get a pulse for people out there. This is a good one. Do you have any CNC machines? This will be interesting to me. CAM is my favorite thing. And I had to abandon one of our demonstrations for the Follow Me IPW. I described it. We'll try to make that available in the web replay. Didn't want to go too over. People have things to do.
Yeah, 3 hours is a pretty good endurance for hanging, but you will have the ability to replay these, and any things we weren't able to get to, we're going to try to make those individually available just as a smaller movements. That's it. All right. So I think we're all set here. Thanks very much for your participation. Remember, there are additional sessions coming up for Solid Edge University. I think we have one in the 25th of this month, and there'll be more information to follow. Thanks again. Take care. Have a good night.